Hi everyone. So today we'll be actually studying about the sequence data type. Okay, in this particular sequence data type, we are going to discuss about the method of indexing. And first, we are going to understand what is actually indexing. So indexing is basically a way to access any individual element from a given collection or a sequence, okay, of elements. Okay, now it can be a string, okay, or a list, array, tuple. Now in this, when there are certain elements, so how do you basically access these elements? Okay, and in mainly in Python, it mainly uses a zero-based indexing. Okay, it means that the first element, if you want to find the address of the first element, the indexing starts from the zero position. Means the first element will be having an address of 0, and the second one will be having an address of 1, and so on. You can also use negative indexing, okay, to access the elements from the end. So if you are accessing the elements from the end, okay, so the address will start from -1, -2, and so on. Okay, and now we will start with the example by taking an example of a string. So here what I have basically done is I have given a variable name, that is my underscore string, in which I have stored, okay, the data as Python. Okay, now here I'm going to try and find out the address for the element that is in the position 0 and then in the position -1. So the syntax that we normally use for actually indexing a particular element is, you have to give print, open bracket, and you have to give the name of the variable that you have defined or the data where you are actually accessing, and then in the square bracket you need to give the element number. So I'm going to give 0 here, okay, and then next I'm using the same syntax and I'm just changing the address as -1. So let us now see what is the output that we actually get here. So the output here that I've received or that I've got is capital P and N. Now capital P is here. So it means for my address 0, the element that I can access is P, and for a -1, it was the last element, that is N. So that is what I said in the starting. When you are trying to access, okay, when you're trying to access the last element, okay, you can call it as right hand side, left hand side access. So when you're accessing an element from the left hand side, okay, so it is like 0, 1, 2, 3, and when you're accessing an element from the right hand side, it is -1, -2, and so on. Okay, I'll just increase the size a bit. Yeah, so the next one is, I've taken a list as an example now. So I've defined the list as my underscore list. Inside the square bracket, I've given a few of the elements, that is 10, 20, 30, 40, 50. Now here I'm going to perform an indexing operation. I'm going to find the element, okay, which is there in position number 1. So I'll give it as the same syntax, the one that I used for the string. I'll use the same index, and it is like in the square bracket I'll give 1, and I'm trying to find out what is the element that is there at the address number 1. Okay, and then I've used -2 here. So in address number 1, when I give this and -2, let us see what are the elements that I will get at the output. So here I'm getting 20 and 40. So the address for the element number 20 is 1, the indexing is 1, and whereas for 40, when I'm coming from the right hand side, it is -2, because this 50 is -1, this 40 is -2. Why? Because when you actually did for the strings, you can see that when I used the indexing, that is -1, so the output was N. Okay, so when you're starting from the right hand side or from the end, it is always the minus. Okay, so basically, to put it in a very simple terms, it is like imagining a row of lockers. Okay, so like if you're going anywhere, you would find these storage lockers in railway stations and all. they will have each locker is denoted with a number. Okay, so basically indexing, it helps you to point out directly to the locker. Okay, if I have a number like 500, so I can directly find out, okay, where is 500 locker. Okay, so same way indexing helps us to identify and access the element that we are searching. Why? Because each element, okay, is actually defined or is having an indexing. Okay, so you want to open by using its number. That is, here in this case, it is index. Okay, whether you are going from starting or ending. Okay, so another example of indexing in a string. Okay, so here again I've taken an example of hello, and I have used the same indexing 0 and -1. Okay, so why not, why 0? Let us take some other number. Okay, we'll give it as 2, and we will give this as -2. Okay, and we'll try to run it. So I'll get L and L. Okay, so if I start from this side, it is 0, 1 and 2. So second element is L, and if I start from the right hand side, -1 and again -2 is L. So I'll get L and L both the times. Okay, so this is just an example. Okay, so here the next one is for the indexing for the list. So again I've taken -2 and 1 this time. Okay, so when I give -2, 2, it is 0, 1 and 2. So 2 is for 30, the element 30 is stored at the position of 2, and 50 is stored at the position -1. So normally we can use positive indices to access the elements from the beginning and negative indices to access the elements from the end. Now, when we look into the arrays, okay, here we are going to use the NumPy. So we will import NumPy, okay, and then carry out our operations. Okay, so first thing is, whenever you're working with an array, it is better to import the NumPy. Give the command as import NumPy as NP. Okay, and then, okay, you should know that arrays work similarly like list, but are more efficient for numerical operations. Because you would have seen that I'm using the same syntax as the list that I've given here, same format inside the square bracket. But the only advantage here is that when it comes to large numerical operations, NumPy is more efficient. Okay, and here I'm accessing with the same syntax. Okay, whatever I've defined for my variable, I'm using the same syntax. So for 1, okay, and I've used the -2. Okay, so same rule, whatever I've applied for the list, the same thing can be used for the array also. So it is 2 and 4. So when I look into the index number 1, what is the data that is stored? 0, and this is 1. So at the address of 1, I have the number element 2 that is stored, and -2, if I go back from here, -1, -2, it is 4 that is actually stored. So that is the output that is reflecting here. Now when it comes to tuple, okay, so tuples are immutable, means it cannot be changed, but are similar to the list in terms of indexing. You should remember this very carefully. Why? Because tuple and list, they are same, but list you can make the change, but tuple you cannot change. That is why they are known as immutable. Mutation means also you can keep changing. Immutable means something that you cannot change. So I have defined my variable over here. I have given it as 100, 200, 300 and 400. Now I'm going to access the element that is there in the address 0 and then -1. It is very simple one. So 0 means I should get 100 and -1 means I should get 400. So 100 and 400. So that is what I have written here also for your reference. Tuples are mainly indexed just like the list, and you can use positive and negative indices both for this. Now when it comes to indexing in the list, okay, the indexing in the sets, sorry. So one of the things that you should know is that sets are unordered, okay, which means you cannot access the element by indexing. You cannot perform the regular indexing like in the list or the tuples. Okay, so let us see what is that error we normally get, or do we will get the output or not. So here we are not getting any output. Okay, why? Because I have commented this. I'll remove this and then I will check if we get the output or not. No, we will get the error because the object is subscriptable. Okay, so when I defined my set as my set 10, 20, 30, 40, I've defined it and I'm trying to access the element that is there, the element 10 which is there in the address 0, that is the indexing number 0, because this will raise an error as sets do not support indexing. So that is what I said. Sets are mainly unordered, okay, and they cannot be accessed by their elements cannot be accessed by the indexing method, okay. So we cannot perform indexing like we did for list or for tuples. That is one of the problems with the set. So on set, you cannot perform indexing. That you should know. Okay. So since sets do not maintain order, there is no way to index the element because you need an order for doing the indexing. Now next we will look into dictionary and we will see that can we perform like what do you call indexing in the dictionaries. And before that, what is actually dictionary? Dictionary is nothing but the normal dictionary that you have. It usually have a key value pairs. Okay. So for example, A is the key and the value for that is 1. Okay. B is the key, for that the value is 2. Like that, it always comes in key and value pairs. Okay. So indexing in dictionaries is done using the key instead of numerical indexes. Okay. So whenever we want to do an indexing, we use the key. Okay, we do not give it as 0, 1, 2, 3. We use the key to get the value, okay, that is stored in that particular key. So I'll give my syntax as print, okay, and then I will write my variable name that I have defined for my dictionary, and then give the value, then give the key value and inside the square bracket. Okay, so I'm giving here A. So it should give me an output of 1 because the 1 is the element that is stored, or 1 is the value that is stored in the key A. Okay. And there is another method also. I can also write it as, okay, my dictionary, that is the name of my variable, dot get. Okay. And then I can give the key value here. So it will give me what is the value that is stored here. So it should be, the output should be 2. And we should know that we can use the key to access the value associated with it. That's what I said. Whatever the value is there associated with a particular key, we can access it. But in place of the numbers, we are giving the key values here. Okay. So when I actually gave the key A, so 1 is associated with A. So that is the output here. And when I gave the key as B, 2 is associated with B, so that is the output. Okay, so the last one is how do we perform the indexing in range? The range function generates a sequence of numbers. Okay, so normally we give the range and it generates the number within that particular range. Okay, we can access a specific number in the sequence using the indexing. Now here we can do it because it is always in the order. So I've defined my variable name as my underscore range. Inside that I'm giving the range as 10. So it generates the number from 0 to 9. Okay. So now I am actually, okay, looking to access the number that is there in the indexing 2 and minus 1. So, okay. So before that, let me see if I will just print the range also. So the range is 0 to 10 and the number that I'm trying to access 2. Okay, I've given that value 2. So it starts from 0. 0 is 0. Then the next one is 1 and the next one is 2. So 2 is there in the indexing for 2 and then minus 1. Minus 1 is the last element. Okay, so the last element is of course 9. Okay, so the output will be 9. Okay, a range object can be indexed like a list. It is similar to a list. Even though it doesn't store the number in the memory, but we can actually access it. Why? Because it is already there in the order. Now, some of the important points that you should actually know is that the zero-based indexing is something where the first element will start with 0. Okay, negative indexing, accessing the element from the end and it will always start from minus 1. Please remember this no matter what. And what is indexing? Indexing is like picking out an individual item from the list of things. So you have a list of things, you need to pick out something. For that, you are specifying the address. That is actually indexing in a very, very simple term. Whether it can be a number, character, object based on its position. So here, for one of the most important thing for indexing is that position is important. You need to know what is the position to access a particular element. And the summary of the indexing is that string, list, arrays, and tuples. These four types, okay, they always support both positive and negative indexing. Please remember this. Okay, that is strings, list, arrays, and tuples. Okay, string, list, arrays, and tuples. They support both positive and negative indexing, no doubt. But sets, it does not support indexing. We have already seen that. Why? Because it is not ordered. Okay, you can see here we got an error when we try to perform indexing on sets. Okay, so this you should know. And dictionaries, when you're performing indexing on dictionaries, you're not going to use numerical, but you're going to use the key. Okay, please remember this. Now, just in case, if in place of this A something, like if I specified Q anything, I would have written Q only here. So we have to give the key there, not the numerical value. Okay, and range, it acts similar to the list and it supports the indexing. Okay, now this is regarding the indexing operation on the sequence data types. Okay, so we have seen how to perform indexing on strings, on list, okay, and then on tuples, arrays. But when it came to set, we got an error because sets, it is unordered, so we cannot perform. Then we did indexing on dictionaries. In dictionaries, you should know that we have to use the keys, not the numerical. And in the range, it is similar to the list. Okay, so that's all for today's lecture. Okay, in the next coming video lectures, we will see some of the other important Python functions that we will be performing. Okay, thank you.